Let's see the question number 7 in set A, CSAT 2025. So what does the question says is, how many possible values of P plus Q plus R are satisfying 1 by P plus 1 by Q plus 1 by R equals to 1, where P, Q and R are natural numbers, not necessarily distinct. So again, first of all, we will look at the input. What is the input given? Input क्या है? P, Q, comma R belongs to natural numbers. This sign is belongs to. And they need to satisfy this question. 1 upon P plus 1 upon Q plus 1 upon R equals to 1. What we have given is, these are not necessarily distinct. They can be same, they can be distinct. So this is our biggest hint in this question. We should always read the entire question, and all words have meaning here. So it has told me that these are natural numbers. That means P, Q, R are integers. Or कौन से integers? Greater than equals to 1. And not necessarily distinct. इसका मतलब ये same भी हो सकते हैं. So the first case I will take is P equals to Q equals to R equals to K. That's it. So what will this give me is 1 by P plus 1 by Q plus 1 by R. I can write it 1 by K plus 1 by K plus 1 by K equals to 1. So this will give me 3 by K is equals to 1. This implies K is equals to 3. So my first answer to this question, the first possible case is P equals to Q equals to R. So P plus Q plus R equals to 9 in this case. In second case, what I will do is P is equals to Q is equals to K1 and R is equals to K2. I will assume this. So if I'll put in the values, so 1 upon K1 plus 1 upon K2 plus 1 upon K1 plus 1 upon K1 plus 1 upon K2 is equals to 1. This implies 2 upon K1 plus 1 upon K2 is equals to 1. Now I cannot solve this equation any further, so I have to take some cases. So by looking at this, these are two positive numbers whose sum should be 1. So if I take K1 equals to 1, so 2 upon 1, this term is 2, which is greater than 1. Not possible. K2 is equals to 2. So 2 upon 2 comes out to be 1. So again, 1 plus something cannot be equal to 1. So 2 cannot be equals to, K1 cannot be equals to 2 either. Let's try K1 equals to 3. 2 by 3, that will give me K2 is equals to 3. This case we have already taken. So let's try K1 equals to 4. This will give me 2 by 4 plus 1 upon K2 is equals to 1. 1 by 2 इधर जाएगा, तो K2 की वैल्यू यहाँ से आ जाएगी. By solving this, K2 is equals to 2. So that's my another value. So P is equals to Q is equals to 4 and R is equals to 2. So one more P plus Q plus R is equals to 4 plus 4, 8, 10. So एक value ये आ गई. So we have found two options, two cases which satisfy the given condition. Now we look at the options. Option A says none, ये गलत हो गया. Option B says 1. Option C says either there are 3 or more than 3. So there is no option for 2. So there exists at least one more value of P, Q, R which is going to satisfy this condition. How do we find that? So what we have seen so far is, if P is equals to Q is equals to R, there is a unique solution where these are equals to 3. If any two of them are equal, be it P equals to Q, be it Q equals to R, be it P is equals to R. If any two of them are equal, then the solution would be 2, 4, 4. We can rearrange them as per the condition. And the question is not asking how many ordered pairs of P, Q, R can be made. It is asking the sum. In any case, the sum will say, sum will be the 10. So that's only one solution will be counted. How do we find the next solution? So for that, we have to observe the equations. 1 by 3 plus 1 by 3 plus 1 by 3 is equals to 1. And I will also write 1 by 2 plus 1 by 4 plus 1 by 4 is equals to 1. So what will happen if I split one of these 1 by 3? I can write 1 by 3 is equals to 1 by 6 plus 1 by 6, because 1 by 6 plus 1 by 6 is equals to 1 by 3, plus 1 by 3 plus 1 by 3 is equals to 1. Let's say I sum these two up. So what will that come? 6, and there will be 3 on the top, plus 1 by 6 plus 1 by 3 equals to 1. This is 1 by 2. So I have found 1 by 2 plus 1 by 3 plus 1 by 6 equals to 1. P, Q, R. All are distinct. So P is equals to 2, Q is equals to 3, R is equals to 6. P plus Q plus R is equals to 3 2 5 8 6 11. So that's the third solution we have found. If I try to do the same thing on this side, let's say the option says there are more than three possibilities. So 1 by 2 plus 1 by 8 plus 1 by 8 plus 1 by 4 is equals to 1. If I try to sum these two, let's try that. So what will it come out to be? 3 upon 8. So this 1 by 8 plus 1 by 2. So this will come out to be 8 by 3. R क्या दिया हुआ है हमें? Integer. All of them are integers greater than 1. So this cannot be possible. If I try to sum these two, so what will it come out to be? 8, 4, 5, 5 by 8 plus 1 by 8 plus 1 by 4. Again, this is 8 by 5, 1 upon 8 by 5. That is also not integer. So this case also not possible. So in exam, I can, by looking at this data, in exam I can confidently mark that there are only 3 values. But for the exam point of view, if you are able to solve this much, that's good enough. But in mathematics, things does not work like this. We have to, if let's just think if somebody wants to prove that there are only 3 values. What about something like 1 upon 11, 1 upon 2, and any kind of random PQR, which are not going to be sum equals to 1? How do I prove that? In mathematics, that is very important, because mathematics is absolute subject. It does not work on proxies and guesses. You have to prove it that there cannot be any more values. Let's assume if you want to learn that. How do we do that? Is there any way to do that? If you have this question, you should watch the video. If you don't, you can stop the video here. So let's see how we are going to do that. So for to prove that, we need to learn the fractions. 1 upon 1 is equals to 1. 1 upon 2 is equals to 0.5. 1 upon 3 is equals to 0.33. 1 upon 4 is equals to 0.25. 1 upon 5 is equals to 0.2. 1 upon 6 is equals to 0.16. 6 पर 12 आएगी. यहाँ पे भी 3 के ऊपर 12 आएगी. 1 upon 7 is equals to 0.142. These fractions should be remembered for everyone. If you want to do the speed maths, this fraction should be remembered by everyone. 1 by 8 is equals to 0.125. I will write couple of more. 1.9 is equals to 0.111. 1 upon 10 is equals to 0.1. Let's do one more. 1 by 11 is equals to 0.99. 0.099 and so on. So if I look at these fractions and their fraction value, I need to make sum of any of these 3 fractions. I cannot pick any 2, any 3 of sum is equals to 1. I have already solved the equation for 3 of a kind. When all of 3 are same. So 1 by 3 plus 1 by 3 plus 1 by 3 is equals to 1. I know that. I also know that if 2 of them are same, 1 by 4 plus 1 by 4 is equals to 1. I have already solved that. There is only a unique solution to them. We found only one solution here, and there cannot be magically one more solution cannot be created for such conditions. This is mathematically only one solution. One case can exist where P is equals to Q is equals to R are same, and their reciprocal sum is equals to 1. And same goes for when any 2 of them are same. Only one solution is going to exist for that condition. The problem is when P is not equals to Q is equals to not equals to R, like in the last slide I saw, any 3 random natural numbers can be picked, and what is the guarantee that there's some reciprocal there's some will not be equals to 1. So let's see I take the first fraction as 1 by 2. Now I have covered 0.5. I need to go to 1. So any two numbers whose sum can be 0.5, only then this identity can be satisfied. Let's start. If I take one of these number as 1 by 3, so I have consumed 0.3333 more. So from 0.5, if I subtract 0.333, I am left with 0.16, that is 1 by 6. And this is the one solution which I found. And we have covered this. We found this on the last slide. That is P is equals to 2, Q is equals to 3, R is equals to 6. Now I say that there are more solutions like this. So 1 by 2 I've already consumed. Like 0.5 I've already consumed. With 1 by 3 I've already consumed 0.33. Is there any another number which can satisfy? I add to this and that equals to 1. If I look at 0.25, so this is 0.33, 0.25, this will be greater than 0.5 because there is not enough margin left. If I add 0.2, so 0.33 plus 0.2 will be 0.53, that is again greater than 0.5, and if we add these two, it will be greater than 1. If I go beyond 1 by 6, if I take 1 by 7, 0.142, so 0.333 plus 0.142, so that will be come out to be 0.47, that is less than 0.5. So no number can satisfy this. If I go beyond 1 by 7, then this number, this sum of these two number will keep dropping, it will keep decreasing because these numbers are smaller and smaller. So I can be sure if first number is 1 by 2, second number is 1 by 3, there is only one solution exists. That I have shown mathematically. Now let's say I have taken 1 by 2. Let's say I don't take 1 by 3 now. I will take 1 by 4. So how much I have consumed? 0.5 I have consumed here, 0.25 I have consumed here. And for this third place, only 0.25 can satisfy this equality. If I take 1 by 4, the solution we have already found. If I put 1 by 5, 0.2. So 0.25 plus 0.2 would be 0.45, which is less than 0.5. 0.5 plus something less than 0.5 is less than 1. And if I keep increasing this number, if I keep going this direction, this sum of these two will keep decreasing. So this number will always be less than 1. So if I take 1 by 2, 1 by 4, then the only solution is this. Okay. What will happen if I take 1 by 2 plus, let's say 1 by 5, and if I add to something here, equals to 1. I have consumed 0.5 here, 0.2 here. So this number should be come out to be 0.3, exactly 0.3. Otherwise, this equality cannot be satisfied. I cannot take anything before 1 by 5 because all those cases we have covered. So if I go in this direction, 1 by 5, if I put 1 by 5, then it is 0.2. Again, it is not going to meet. 0.16, 1 by 6 is 0.16, which is even less than 0.2. So this number again will be less than 0.5 and our equality will never be satisfied. So I can assure you, if we have looked into this much of the data, so if I take 1 by 6, again the problem will become 1 by 6 is only again 1.16, and this number should be less than this, 0.142. It will never be satisfied. It will never become equal to 0.5. So, but now the doubt is, what if we change the initial 1 by 2? What will happen then? If I take 1 by 3 plus, now I cannot take 1 by 2 because those cases have been covered. I can at max take 1 by 3 plus something should be equals to 1. So that something is 0.33 bar, and that is exactly 1 by 3. Let's assume if I put 1 by 4 here, so that will come out to be 0.25. Again, that number is less than 0.333 bar. So in this situation again, there is only one case which exists. This number has to be 1 by 3, otherwise equality will never be achieved. So if I take 1 by 3 plus 1 by 4 plus something should be equals to 1. So how much I already consumed? 0.33 plus 0.25. So I have consumed approximately 5 3 8 3 2 5 0.58. The biggest number after 1 by 4 is 1 by 4 itself, and I need 0.42 here. Is there any way I can bring a 0.42 here? No, there is no way, because the 1 by 4 itself is less than 0.42. Any number greater than that will be less than 0.42. Okay, so now again the same thing. If I keep changing 1 by 4 for 1 by 5, 1 by 6, the same thing will keep happening. And if I take any other number apart from 1 by 3, if I take 1 by 4 plus something is equals to 1. So if that is only 2.25, that something should be 0.75. There is only one case which we have already taken, 1 by 2 plus 1 by 4. And there is no another case where this number can, sum of two numbers can become 0.75. If I take all three 1 by 4 plus 1 by 4, 1 by 4 plus 1 by 4 plus 1 by 4, the number will reach 0.75. That there will be deficient of 0.25. If I take anything lesser than 1 by 4 here, like 1 by 5 plus 1 by 5, so 0.2 plus 0.2, it will be 0.4, which is less than 0.75. So by showing these calculation, or by doing this calculation yourself, you can confidently say that there is a mathematical proof like this number, sum of these numbers is equals to 1, where P, Q, R are natural numbers. There are only three cases which can satisfy this equation. There are no other cases. That's all for today. If you have any doubts, you can leave a comment. Otherwise, do like, share and subscribe. Thank you. We will meet again in the next video.